Hello everyone and welcome back to the IGCSE 0606 Additional Mathematics course. In this video we will be covering chapter 10, which is trigonometry. So let's get started. So the first thing, let me just introduce trigonometry to you. Trigonometry is an area that basically deals with angles and sides in a triangle. Well, that's the more basic form. So given a right angle triangle with sides ABC, you should be familiar with the Pythagorean theorem: a squared plus b squared is c squared. But now we introduce trigonometry. So trigonometry has these six basic functions: sine, cos, tan, and then the reciprocals of these: cosecant, secant, and cotangent. So tan is tangent. And so basically, if we say the sine of some angle theta will be b over c, cosine of that angle theta will be a over c, and then the tangent will be b over a. And then obviously these are reciprocal. So cosecant reciprocal of sine, secant the reciprocal of cos, and then cot the reciprocal of tan. So an easy mnemonic to remember the trigonometric functions is that sine is the opposite, so opposite to the angle divided by the hypotenuse, which is c. Cos is the adjacent, so adjacent side to the angle is a divided by the hypotenuse, and then tan is opposite by adjacent. So you say so toa, so opposite by hypotenuse, adjacent by hypotenuse, and then opposite by adjacent. And then if you actually paid attention here, or you might have seen that tan theta is equal to sine theta by cos theta. So tan theta b by c divided by a by c is equal to b by c into c by a, which is equal to b by a. And then we know by definition that tan theta is b by a, so we can say that tan theta is sine theta by cos theta. Right. Moving on to the graphs of the trigonometric functions. Here we have y is equal to sine x, y is equal to cos x, and y is equal to tan x. So I haven't actually labeled the axes here, but basically the range of the sine x function is 1 to -1. Same with cosine. And then tan x just has a range of positive infinity to negative infinity, and we'll talk about these dashed lines in a second. So at this point here is 0, 0. This point here is actually 90 degrees, gives you positive 1, so sine 90 is 1. Or if you know from the previous chapter of radians and degrees, you will know that 90 degrees is also pi by 2. So pi by 2, sine pi by 2 is 1. Then over here, I'll just use radians from now because it's small, like simpler to write, and it's shorter. So sine pi is 0. Then we've got degrees 270, or 3 pi by 2. That gives you -1. And then 2 pi here gives you 0 back again. Then obviously you've got the negative side, so minus pi by 2, minus pi, minus 3 pi by 2, and then minus 2 pi. So as you can see, this is a periodic function, so the domain is actually infinite, but most questions actually specify the domain because obviously you can't have, they won't ask you for infinite roots. And then same thing for cosine. So as you can, so 0 gives you 1, and then we come down here, this is 90, this is pi, 180 is -1, 3 pi by 2, and then 2 pi is back up to 1. And then cosine x is actually just reflection of the y-axis, so this is again negative pi by 2, negative pi, negative 3 pi by 2, and negative 2 pi. Now, tan x is a bit different because it has something called asymptotes. So these dashed lines represent asymptotes, where if you remember from exponential and logarithmic functions, an asymptote is a line which the curve approaches but never actually touches. So the tan x function will approach this line forever until positive infinity, but will never actually reach this x point. So as you can see here, this is 0, and this first asymptote exists at pi by 2. This again here will be pi, and then the second asymptote here at 3 pi by 2, followed by 2 pi being 0 again. So 90 and 270 are the asymptotes. Similar on this side, just to take the negative parts. So negative pi by 2, negative pi, negative 3 pi by 2, and negative 2 pi. Asymptotes are negative pi by 2 and negative 3 pi by 2. Those are the basic functions of the trigonometric. Those are the basic graphs of the trigonometric functions. Now, we come to these transformations basically. So if you have a graph a sine bx plus c, a function like this, we say that a is the amplitude. So here the distance from 0, the x-axis essentially, to the highest point of the graph. This distance on the y scale is the amplitude. All right, now b. So basically, if the so domain is given in degrees, you will use 360. If the domain is given in radians, you'll use 2 pi. But basically, whatever, so 360 or 2 pi divided by b gives you the period. So what the period is basically when the function repeats. So if we come over here, we can see that b value is 1 here. So the function repeats every 2 pi radians, or every 360 degrees the function repeats. So that's what the period is. After how many intervals does the function repeat? And then c is just the y-intercept for, as always, it's just the y-intercept for any graph. If we come over here to y is equal to a cos bx plus c, these two are actually the same. The y-intercept is a little bit different because the cosine of 0 is 1, and then because 1 times a is just a, the y-intercept is actually a plus c. Because sine 0 is 0, we only use c. And then the same thing here, the period 2 pi by b, and then the amplitude is a. Now, because now tan is again different from the other two completely, because since it has a range of positive infinity to negative infinity, a isn't actually the highest, or the amplitude is actually the gradient at the given point, which you don't technically need to know, but basically the higher the value of a, the higher the gradient at that point. Now the period is again the same thing, but it's actually 180 or pi instead of 360. So as you can see, basically the distance between, just for it to be simpler, we just take the distance between the two successive asymptotes, and then c is once again the y-intercept. Okay, now these are some identities that you don't actually need to remember because they'll be given in the list of formulas, but you will need them when proving any trigonometric relations. So if you want to see some example questions, refer to the notes that are in the Google Drive in the description below. Now, if we come over here to actually solving trigonometric equations. So if you'll remember, this is the x-axis, this is the y-axis, and we say, so this first quadrant, second quadrant, the third quadrant, and then the fourth quadrant. So in the first quadrant, A stands for all, and that basically means that all the functions are positive here. We'll come to what that means. Second quadrant, S stands for sine, which means that only sine is positive here. Third one is tan, meaning that only tan is positive here. And then the fourth one is cosine, which means that only cosine is positive here. So what does that actually mean? Well, if we come down here, we can see that this angle is actually 0 degrees or 360 degrees, because if you do one complete rotation, you'll come back here at 360, or alternatively the radians, which is 0 or 2 pi, right? Both of these are the same. So 360 plus some angle theta, obviously with theta being less than 90 and greater than 0, we can say that if we have, let's say, some angle theta here, then sine will be positive, and then from this line of 180 degrees, if we have another angle theta but in the opposite direction, so let's say like this and some line here, theta, then 180 minus theta is equal to sine theta. So let's say if I were to take sine, let's say theta is equal to 45 for instance. So we know using our calculators, or actually this, you should probably also memorize the values, but sine 45 gives you root 2 by 2, and then using the formula to prove them, we say that sine 405, we test that also, or 0.5 also gives you root 2 by 2. Sine 135 should also give you root 2 by 2, which it does. And then the last one is basically that sine theta is equal to negative of sine negative theta. So what that basically means is, because if we take theta to be this anti-clockwise direction, then we take sine negative theta to go in this other direction, which is again off theta. So if you see, this line here is actually just a negative of this line, because if you recall, negative is just a reflection in the x-axis. So that's the geometrical representation of it. If you just take sine negative 45, you'll see that is negative root 2 by 2, which is the negative of root 2 by 2. Okay. Now coming over to cosine, again, same cosine falls in the first quadrant for all, so 360 plus theta, and it also falls in the fourth quadrant, which is 360 minus theta. And then cosine, because of its this property, whether it's a reflection in the y-axis, we say that cosine negative theta is just cosine theta. And then tangent doesn't actually, you don't actually need to remember this one, but basically if you have a root, you can just keep adding 180 or subtracting 180 from that starting point, and you'll just keep getting your roots because of the asymptotes and its period being 180. That doesn't work with these two because they actually have other forms, 180 minus and 360 minus. So yeah, if you want some example questions, those will be in the, again, the notes document with the PDF. But yeah, actually, you know what, I'll cover this also, some basic uh, things. See, okay, sine, cosine, tangent. So 0 1 0 1 0 1, I believe. Yeah, let me recall this. Oh wait, no, actually that is the, let's just say NA for asymptote. Well, this just means asymptote here, right? Okay, now sine. So if you actually remember sine and cos, you can just divide the two values to get tan. But sine 30 is 1 by 2. I'll tell you a way to remember this in just a second. Let me just fill out the table quickly, right? Uh, 3 by 2. This should be root 2 by 2. And then this should just be 1 by 2. Yep. And then this is what? The division, which is 1 root 3 by 3. Yep. This is just 1 because they're the same thing. This should be the opposite value, which is root 3 or 3 by root 3. And so if you look here, think this will be what? Yeah, okay. So if you see here, if we go upward from sine, cosine is just the reverse. As you can see, for 30 is 60, and then 60 is 30 for these two. Tan is just third division, right? Yep. This table you will need to remember, I think, for the non-calculator paper. I'm fairly certain these will be the only angles that come. You can use this formula to get these if you're given like 135 or some weird angle like that. So we found out sine 135 and sine 45 are the same thing, but how to remember sine, I guess, is the major problem. So this is 0 by 4, I think. Yep, this is root 1 by 4, root 2 by 4, and then root 3 by 4, right? Yeah, okay. So yeah, if you just remember, 0 is 0, 30 is 1, so basically root 1 by 4 is 1 by 2, root 2 by 4 is root 2 by 2, and root 3 by 4 is root 3 all over 2, root 4 by 4 is just the square root of 1, which is 1. So 0, 1, 2, 3, 4, these are the first 5 whole numbers, and they correspond to these angles in increasing order as well. So if you just remember these, sine You remember sine values. Cosine is the exact opposite, and then tan is just division. You can remember these basic angles as well. And yeah, that's about it for trigonometry. Thank you for watching.